Alright, so we are on our last set of notes for the chemistry unit. We are going over physical and chemical changes as well as law of conservation of mass. So go ahead and title your notes for today, Evidence of Chemical Changes, and get your Cornell notes set up. And go ahead and pause here. Your essential questions, so what you're going to be writing on the very top. How does evidence of chemical reactions indicate that new substances with different properties are formed? Go ahead and pause the video here if you're still writing. Alright, so your chemical reactions, it occurs when two or more molecules interact and the molecules change into a new substance. Bonds between atoms are broken and created to form new molecules. So the example that they gave you was CH4, which is methane, and oxygen atoms. Those are your reactants. And then you have the arrows showing you that it changed and formed into two products, and your products are carbon dioxide and two water molecules. Go ahead and pause here if you're still writing. Alright, so examples of physical changes: whipping eggs, boiling water, dissolving sugar, dicing vegetables. It changes the form or appearance of a substance. It does not change the substance into anything new. Go ahead and pause here if you're still writing. So physical changes, it's changing the state of matter, changing the color, changing the temperature, changing the shape, and changing the texture. So just like ice melting into water, physical changes are limited to changes that result in a difference in display without changing the composition. So you're not changing that chemical composition into something else. Other changes could be changing of the state, which is the first one on there. So boiling point and melting point are significant factors in determining this change. Physical properties include other aspects: the luster, malleability, ability to be drawn into a thin wire, density, viscosity, solubility, mass, volume. So all of that is part of the physical change. Go ahead and pause here if you are still writing. Alright, so chemical changes, it's when two or more substances join to form new substances with new chemical properties. So we have our examples. We have our iron that is rusting. We have gas burning. You have bread rising and eggs cooking. Those are our examples of a chemical change. Go ahead and pause here if you are still writing. So, going more in depth with chemical changes, unexpected color change. So, new molecules created in a chemical reaction radiate light differently, producing new colors. So, the examples for this one are fireworks and when the leaves change the color in the fall. So go ahead and make sure you highlight that in your notes. Pause here if you're still writing. Alright, so unexpected temperature change. During chemical bonding, energy is released or absorbed, making their surroundings hotter or cooler. Examples: adding baking soda to vinegar causes the temperature to decrease, and your body temperature increases to fight infections, so when you get sick. Those are examples of the temperature changes. Go ahead and pause here if you're still writing. Alright, so we have combustion, burning, a chemical reaction between substances, usually including oxygen, accompanied by giving off heat or light. This is a permanent change that cannot be undone. So wood burning, candle, and rusting. So when you're burning the wood, you can't do anything with like the ashes from the wood. That cannot go back to being, a piece of wood. So make sure you write that down, highlight what I've highlighted, and then go ahead and pause here if you're still writing. Next one, precipitates form. So when a solid suddenly appears in a solution and settles to the bottom, collects on another object, or makes the solution cloudy. The examples is when the milk is souring or bathtub rings. Go ahead and pause here if you're still writing. So bubble forming is another one. When gases are produced, that is an example of a chemical reaction. Examples are the Alka-Seltzer tablets and bubbles in soda. Alright, so you are going to write this acronym down. This is going to help you when you're observing chemical reactions in lab. Please get off the couch. So precipitate, gas, odor, temperature change, and color change. That's what you're looking for when you're deciding if it's a chemical reaction or a physical reaction. You only need to observe at least one of those to know if it's a chemical change or not. Go ahead and pause here if you're still writing. So, what would I see during a chemical reaction? While atoms are rearranging, you may see one or more indicators of a chemical change. Once the reaction is over, the atoms will be in equilibrium and you will not see the indicators. So you have to, when you're in lab, as soon as you mix the two chemicals together, you should be observing right away, because that's when you'll see the change. After a while, like with the Alka-Seltzer and stuff like that, it settles down, so you won't be able to observe that anymore. Go ahead and pause here if you're still writing. Alright, so we're going more in depth with the temperature changes. You have exothermic and then you have endothermic. So we're looking at the exothermic first. It's a reaction that releases heat energy. The reaction will feel warm until it reaches equilibrium, and the heat is a product in an experiment. So in an exothermic reaction, energy is released into the surroundings as heat. As a result, the temperature of the surroundings increase. Alright, going into the endothermic now. It's a reaction that absorbs heat from the atmosphere. The reaction will feel cold until it reaches equilibrium, so until that reaction has stopped. Heat is a reactant in an experiment, so you're going to have the heat at first, but it's not going to be the product. So in an endothermic reaction, energy is absorbed from the surroundings. As a result, the temperature of the surroundings drop. Go ahead and pause here if you're still writing this table. So, what is a chemical equation? You guys have seen this maybe once or twice before. A chemical equation shows the amount of atoms and elements involved in the equation. The reactants, substances reacting, are always on the left side, and the products and the substances formed are always on the right side. So, react, these two compounds are going to react to create your products. So you can see how many carbons you have and how many hydrogens you have and how many oxygens you have. Make sure that you write this whole part down. This is the equation for photosynthesis. Go ahead and pause here if you are still writing. So, the law of conservation of mass, or matter, during a chemical reaction, atoms will rearrange to form new substances with new properties. Matter is not created nor destroyed, so the total number of reactants will be equal to the total number of products. Which of the following equations proves the law of conservation of matter? So for this, for the first one, we have 6 white, we have 4 black dots, and then for your products, we have 2 white and 4 black. So the first one would not work because there's 6 white as the reactants and 2 whites as the products. So immediately that can get crossed out. The next one, you have 3 white on the left and 3 white on the right. And you have 3 black on the left and 3 black on the right. So the second one proves or shows the example of the law of conservation of matter. Going on to the next one, there are 3 black and only 2 black, so we know that one doesn't work. And then you have, for the last one, you have 3 white and 4 white, so you know this one doesn't work. So the correct balanced equation is the second one. So you have to have the same amount of atoms in the reactants and in the products to be in a right equation. If that doesn't happen, then there's no product that's going to occur. And no information about the relationship between products and reactions in the reactants can be derived. So go ahead and pause here if you are still writing. Alright, so which of the following equations proves the law of conservation of matter? So be able to explain. For this, for A, B, C, and D, you need to count the total number of atoms of each element on the reactant side and on the product side. Hold on. Okay. So I want you to write this whole, not the whole question down, but just the bullet point, and then write down A, B, C, and D, and then tell me how many Na, how many sodiums, how many chlorines, how many sulfurs, how many oxygens are on the reactant side, and then tell me the same thing on the product side. And you're going to do that for each one. Even when you find the answer, I want you to still get practice of knowing how to balance or how to find if an equation is balanced or not. Go ahead and pause here. Alright, so for this slide, you're not telling me if it is a law of conservation of mass equation, but you are going to tell me if it's endothermic or exothermic. So for this, I want you to go back to your notes, and in your notes it talked about which one, so exo or endo, occurs in the product or the reactant. So basically, when the heat is leaving, heat is also another term for energy. So you need to figure out in your notes which term goes with the reactant side and which term goes with the product side. And you're going to write that down. You do not need to write the equation down. And go ahead and pause here while you complete this. Alright, so for this slide, you're going to click on the link below in the description of my video, or you can just type in the link in the green font. You're going to answer the following questions on the right. Go ahead and pause here. Now that you completed watching the video, can you investigate how evidence of chemical reactions indicate that new substances with different properties are formed? And then on this slide, I want you to answer these questions. And this will be your summary that you usually do at the end. Once you finish that, you are done with your notes.